This board is a combination of a relay and valve board. 3 valves are used, one for main air, one to extend the welder cylinder, and the third goes to the vacuum generator controlling our suction gripper. Here's our MCR, and all of our crosstalk relays, and a contactor for the welder, due to the amount of amperage drawn while welding. This is our Siemens S7-1200 CPU and I/O modules. This is our FANUC CPU and I/O modules. Both Siemens and the FANUC use a 24 voltage direct current, which is supplied by the transformer. We also have a separate power supply for the magnetic gripper. The hot AC lines run through the circuit breakers supplying the circuit with power. These circuit breakers control the input going into the power supply and also the output going into the power supply. This is our human machine interface, or HMI. On the HMI screen is a reset button. When pressed, the FANUC user operator panel reset turns on, resetting any faults on the FANUC. The double operator start, E-stop, pressure gauge, and also MCR is located on the HMI. These are the stack lights. Green indicates when the program is running, amber for when the MCR is on causing power to come high, and red for when there is a fault in the program. This is our normally closed E-stop. When pressed, the FANUC UOP hold is faulted, causing the arm to halt.
The double operator start requires the personnel to press each button simultaneously. This signals the FANUC UOP start, which enables the robot and runs the program. Physical barriers are used to prevent personnel from entering the work envelope. The signs are used to make aware of the possible hazards that are within the work envelope itself.
Just like the E-stop, the light curtain is normally closed and will also fault the FANUC hold when broken.
This is the pedal feeder. The main shape is based off the pedal, which fits here. A chamfer is also used to allow compliance to the operator when loading. The slot in the side, here, allows the operator to remove pedals if needed. This is an inductive proximity sensor which detects when a pedal is present. The signal is then sent to the FANUC using crosstalk relays to notify a pedal is present and it may be picked up.
This is the stem feeder. Again, the main shape is based around the stem. At the top, a 30-degree chamfer is used to allow compliance for the operator. A slot is also on the side of the fixture to allow the operator to remove the stems if needed. The proximity sensor is located in the rear of the fixture and indicates that a stem is present to the fan.
The cylinder extends and retracts the welder. As you can see, the cylinder has 2 pivot points which allow the arm to be extended and retracted.
This is the welding fixture. The robot will wait until the welder arm is clear. When the welder is clear, a stem will be placed on the fixture. There is compliance for both the stem and pedals. Once placed, it is recognized by a proximity sensor. After the stem is placed, 3 pedals will be placed as well, which are also recognized by proximity sensors. After a stem and 3 pedals are placed, the welding cylinder will retract, holding the pedals and stem together.
After welded and the welder clear, the FANUC will pick up the flour, moving it to the cooling station. Once the proximity sensor here has been met, the fan will turn on, cooling the flour. Once cooled, the flour is moved to the gravity chute. The FANUC will drop the flour, which will slide down the chute, making final product ready to be picked up outside the work envelope.
Ready, set, let's roll.
Cottonwood falling like snow in July.
Said fireflies popping like a 4th of July, yeah.
Breeze blowing in, your hair blowing round. You're scanning through the stations looking for that country sound.
Trucks jacked up, flat bills flip back.
It's going down just right.